Ever scanned a QR code and just marveled at the sheer magic of it? You point your phone at this weird, pixelated black and white square, and bam, you're on a website looking at a menu or connected to Wi-Fi. It feels like a portal to another dimension, a digital key that just works. But how? How does this little square hold so much information? And how does your phone decipher its secrets in less than a second? Well, today, we're pulling back the curtain on this everyday enigma. We're going to decode the decoder and reveal the surprisingly clever technology packed into every single QR code. First off, what does QR even stand for? It means quick response, and that name is no joke. These codes were designed in Japan back in 1994 by a company called Denso Wave, initially to track automotive parts during manufacturing. They needed something that could be scanned faster and hold way more information than the traditional barcodes you see on your groceries. And boy, did they succeed. A standard barcode can only hold about 20 characters of information, and it only works in one direction horizontally. But a QR code, it's two-dimensional, reading both horizontally and vertically, which allows it to store a massive amount of data. We're talking thousands of alphanumeric characters. That's enough to hold a whole paragraph, a website URL, contact information, or even a Wi-Fi password. So, let's get into the anatomy of a QR code. It's not just a random jumble of squares. Every part of it has a specific purpose. Think of it like a digital map. The most noticeable features are those three big squares in the corners. These are called position detection patterns. They are the anchors of the code. Their job is to tell your phone's camera exactly how the code is oriented, scanned at a weird angle. These three markers allow the scanning software to instantly correct for any distortion, rotating and aligning the image digitally so it can be read properly. It's like having a built-in GPS for the scanner. You might notice there isn't a fourth square in the bottom right corner. That's intentional. The absence of that fourth square helps the software confirm the orientation and prevents it from getting confused. There's also often a smaller square, called an alignment pattern, located somewhere within the grid. This helps the scanner deal with distortions if the code is large or printed on a curved surface. Now for the magic part, the data itself. All those tiny black and white squares, or modules, are what store the information. They work using a binary system, the fundamental language of computers. A black module might represent a 1, and a white module might represent a 0. Your phone's camera captures the image, and the scanning app analyzes the pattern of these light and dark squares, converting them into a long string of 1s and 0s. This binary data is then translated back into a format that humans can understand, like text, a URL, or contact details. But what happens if the QR code is damaged? Maybe it's printed on a restaurant menu that has a coffee stain on it, or it's on a poster that's been scratched. This is where QR codes show off their most brilliant feature: error correction. Embedded within the code itself is redundant data extra information that acts as a backup. It's based on a clever mathematical principle called the Reed-Solomon error correction algorithm. This system allows the code to be partially obscured or damaged and still be perfectly readable. There are actually 4 different levels of error correction you can choose from when creating a QR code. The lowest level can withstand about 7% of the data being damaged, while the highest level can recover from up to 30% damage. That's almost a third of the code. This built-in resilience is a huge reason why QR codes are so reliable and practical for real-world use. It's like the code has its own built-in insurance policy. Have you ever wondered about those colorful QR codes with a logo in the middle? You might think that would mess up the whole system, but thanks to that amazing error correction, it doesn't, as long as the contrast between the light and dark modules is high enough for the camera to distinguish them, and as long as the logo or design does uncover up too much of the data, especially those crucial corner squares, the code will still work. The error correction feature essentially fills in the gaps created by the logo, allowing the scanner to reconstruct the full data set. This has allowed for a whole new level of creative branding, with QR codes, turning them from simple functional tools into eye-catching marketing assets. So, how does the scanner know what it's looking at? Near the position markers, there's another crucial piece of information called the format information. This little section tells the scanner what level of error correction is being used and what kind of masking pattern has been applied to the code. A masking pattern is a filter used to break up large areas of same-colored squares, which can sometimes confuse scanners. It ensures a good balance of black and white modules across the grid. The format information is repeated in the code to ensure it can be read, even if part of it is damaged. There's also version information. There are 40 different versions of QR codes, each with a different size and data capacity. Version 1 is a tiny 21 by 21 grid, while version 40 is a massive 177 by 177 grid that can hold a huge amount of data. The version information, located near 2 of the main corner squares, tells the scanner exactly how big the grid is, so it knows how to interpret the data. One of the most fascinating things about QR codes is that the technology is open source. The patent is held by DensoWave, but they chose not to exercise their rights, meaning anyone can create and use QR codes for free. This is a huge reason for their explosion in popularity. You don't need any special software or to pay any licensing fees. There are countless free generators online where you can create your own QR code in seconds. This accessibility, combined with the fact that nearly every modern smartphone has a built-in QR scanner, has made them ubiquitous. From boarding passes at the airport to payment systems in stores, from sharing Wi-Fi passwords with guests to accessing AR experiences at museums, QR codes have seamlessly integrated into our daily lives. Here's a cool experiment you can try at home to see this all in action. Go to a free QR code generator online and create a code that links to your favorite website. Print it out. Now, try scanning it from different angles. Tilt it. Notice how fast your phone still reads it. Now, take a marker and color over a small part of the code, not one of the big corner squares, but some of the data modules in the middle. Try scanning it again. Chances are, it will still work perfectly because of the error correction. You're literally watching advanced mathematics save the day in real time. Another common misconception is that QR codes need the internet to work. That's not entirely true. The information itself, the text, the number, the password's physically encoded in the pattern of squares. Your phone can read and display that information completely offline. The internet only comes into play if the decoded information is a URL that directs your phone to a website. So, a QR code containing contact information or a simple text message doesn't need any connection at all. The data lives inside the code itself. So, the next time you scan a QR code, take a moment to appreciate the incredible amount of thought and engineering packed into that tiny square. It's not just a black and white pattern. It's a masterpiece of data, compression, geometry, and error correction wizardry. It's a testament to how elegant design can solve complex problems in a way that feels simple, intuitive, and almost like magic. You're not just opening a link, you're unlocking a powerful piece of technology with a single tap. Thanks so much for watching and diving deep into the world of QR codes with me. If you found this interesting, be sure to hit that like button and subscribe for more deep dives into the tech that shapes our world. Until next time, stay curious.